Chapter 1, Part 2, the particulate nature of matter. In this class, we're going to cover solids, liquids, and gases. And we'll talk a little bit about plasmas, which is a fourth state of matter, but it's kind of exotic and doesn't exist on Earth very often. But if you've ever seen one of those toys, there's a glass ball and it looks like there's electricity going through the gas and touching the edge of the glass. And if you put your hand on it, all the electricity goes to your hand. You've seen a plasma. It's an electrically conductive gas in which electrons have been stripped off the gas particles, and so the electricity can flow through the gas easily. On a microscopic level, all matter is composed of atoms, tiny, discrete, fundamental particles. And in chemistry, they are the basic unit. You either have an atom or you do not have an atom. There are no halves of atoms, no thirds, no fourths. You either have one or you don't. And the technology has come to the point where, with a scanning tunneling microscope, we can actually see evidence of individual atoms. A scanning tunneling microscope, this is like the world's most sensitive record player. Basically, it just drags a needle over a substance, and it's so sensitive that the electrons at the tip of the needle are repelled by the electrons in the electron cloud of the atoms of whatever it's being dragged over, and it basically gives you atomic resolution. So, solids, liquids, and gases. A solid has a definite shape and a definite volume. The intermolecular forces are so strong that the molecules hold together and hold their shape. And so here we see ice. Ice is a crystalline solid. There's two types of solids, crystalline and amorphous. In a crystalline solid, as we can see over here, it forms a regular repeating three-dimensional lattice, and that is a crystalline solid. An amorphous solid resembles a frozen liquid. The molecules are arranged completely randomly, and they look like it was a liquid frozen in time. And so while crystal is a crystalline solid, glass is an amorphous solid, which is why crystal is cut and glass is worked by a glass blower. Very different tools, because it's actually a very different solid structure. And there was also an interesting argument in chemistry about glass. When you find churches that are 1,000 years old, in general the glass is a little bit thicker at the bottom of each window pane than the top. And so the question was offered, was glass just a really, really, really thick liquid that takes hundreds of years for it to slowly drip down? And finally that was disproven. Glass is definitely an amorphous solid. And what they realized is, once they finally found an old manuscript, is that back 1,000 years ago they weren't able to make glass completely uniform throughout, so there was a thicker edge, and that just was, construction workers were instructed to put that thicker edge at the bottom because that just seemed more stable that way. And then that's why we always run into that. Liquids have a definite volume but no definite shape. Now, some of the intermolecular forces have been broken, and while the atoms are all stuck together, they are free to flow by each other. And so we have a liquid, like liquid water. And then we have a gas, no definite volume, no definite shape. It'll always expand and completely fill its container. Gases can be compressed easily and expanded easily. Solids and liquids cannot. It is very, very difficult to compress a solid or a liquid, but it's very easy to compress a gas. And again, attractive forces are what hold these atoms together and give them their appearance of continuity. Attractive forces are strongest in solids, which is why they hold their own shape. It's weaker in liquids, and then the attractive forces are almost non-existent in gases. And so the gas particles basically behave independently of each other. And here in the PowerPoint you get a list of some common solids, some common liquids, and some common gases that you can run into. Classifying matter. A pure substance has a definite fixed composition. It can be either an element or a compound. And compounds are unique, like water. Water is H2O. It is made of hydrogen and oxygen. But it's nothing like hydrogen gas. It's nothing like oxygen gas. It is water. It is a unique substance with unique chemical and physical properties. And so compounds, even though they're made up of elements, are actually their own unique substances. So the sugar on this spoon is a unique substance. It's sucrose. The water in the beaker is a unique substance. It's water. And if you put them together, now we have a mixture. A mixture is two or more pure substances together. And a mixture can either be homogeneous or heterogeneous. If the mixture is 100% identical, literally everywhere in the mixture, it is homogeneous. If it is not 100% identical everywhere, it is heterogeneous. So if it's a homogeneous mixture, you should be able to grab 200 samples at random places and they should all be identical. It should be absolutely identical literally everywhere in the mixture. If it's not absolutely identical everywhere, it is not homogeneous. It is heterogeneous. And sometimes a heterogeneous system can be just one type of molecule, like ice water. Ice is H2O. Liquid water is H2O. But ice water is not a homogeneous system because it is not exactly 100% identical everywhere. In ice water, the ice floats. And so at the top of it, there's a lot of solid water. And at the bottom, there's no solid water. It's just liquid water. And so it's not exactly 100% the same because even though it's all H2O, it's in two different phases. And so again, if it is not literally, completely, absolutely 100% identical everywhere, it is not homogeneous. If it's different anywhere, like ice water, it is heterogeneous. So here we dissolve the sugar into the water and now we have a homogeneous mixture. When you first dump the sugar in, it's heterogeneous because the sugar falls to the bottom. There's a lot of sugar at the bottom, there's no sugar at the top. But if you stir it long enough so that it all completely dissolves, it becomes homogeneous. And we'll get back to that in chapter 14 when we're studying solutions. Homogeneous mixtures are always solutions because only by dissolving can you get complete uniformity in the mixture. Heterogeneous mixture will have different compositions depending on where the sample is taken. Oil and water form a heterogeneous mixture. The oil layer floats on top of the water layer. And here, they purposely used different liquids that don't mix with each other and carefully layered them on top of each other for this effect. The components of a mixture do not lose their identities, and they can always be separated by physical means. And so if you have a mixture, you can always separate the mixture without doing any chemistry. Like salt water, you can distill it and get the water back and have the salt back. You can filter it, you can use magnetics if you need. But if you have a mixture, it's always possible to completely separate the mixture without doing any chemistry. So here we have a mixture of sulfur and magnetic iron, and they use a magnet to separate them. All mixtures can be separated by physical means. No chemistry is necessary. So which of the following is a heterogeneous mixture? Well, baking soda is just sodium bicarbonate. It's one pure substance. Gasoline is a mixture, but it should be a homogeneous mixture. Hopefully, your first gallon of gas is exactly the same as your second gallon of gas is exactly the same as all of your gallons of gas. They hopefully are all the same because they're supposed to be. Grape juice. If you buy a bottle of grape juice at the store, hopefully it's all the same. Your first glass should hopefully taste just like your last glass. It should be all the same. Copper metal is just one pure substance. But soil is a heterogeneous mixture. Soil can be different. Depending on where you dig, you can get different types of soil, more clay, less clay. And so soil is not the same everywhere. And so soil is the answer. Which of the following is a homogeneous mixture? Well, carbon dioxide and mercury are just pure substances. Concrete is a heterogeneous mixture because concrete is cement with rocks and other things to fill up space thrown in there, and those rocks are not uniformly distributed. Italian salad dressing is a heterogeneous mixture. It doesn't really mix well. You can shake it up and get a temporary emulsion, but it never mixes together. But maple syrup is a homogeneous mixture. If you go to the store and buy real maple syrup, your first pancake should taste like your last pancake. Filtration is a common method to separate what type of mixture. And if we filter something, like let's say we're making coffee, the filter will catch the solid and let the liquid go through. So it's especially useful with a heterogeneous mixture of solid in a liquid, because it'll catch the solid and drain off the liquid. And that is the end of chapter 1.